All right, guys, welcome back to the CCIE Routing and Mentorship Program. Today we're going to talk about EIGRP Named mode. In our last lesson, we did EIGRP Classic configuration, where we had all of our EIGRP configurations using router EIGRP, and we had some interface-specific configurations and so on. We'll do a little bit of review on that in this particular lab, and then we'll take a look at the conversion of EIGRP to what we call the named mode configuration. Now, as far as what you're going to need to know about this for the written exam and the lab exam, it's certainly going to be covered on the written exam. It's a fairly new feature. It was released in 15.x, so and built into the syntax wrapper for iOS 15.x. But it's definitely something that you will be tested on the written exam. Now, when I took my lab exam, they weren't using 15 code, so when I took my lab exam, we didn't have a chance to even configure this, but it is highly possible that they may have you either convert an existing classic mode configuration to named mode, or maybe set up EIGRP in named mode to start. So we'll take a look at the configuration. This particular type of configuration also happens to be called multi-address family configuration mode, because we're actually going to be setting up EIGRP using IPv4 and IPv6 address families. So that's something that you may be familiar with if you've ever worked with multi-protocol BGP, and it's a very similar concept in EIGRP. Now, unlike OSPF v3, we're going to see OSPF v3 a little bit later on when we get into our OSPF configurations. We are still using two separate transports for the EIGRP data. When we're doing OSPF v3, which is very similar to the named configuration mode, but for OSPF, we're transporting all of our OSPF packet types for v4 and v6 inside of a v6 datagram. In this particular case, though, we're still running, and we'll see this in the Wireshark captures, we're still running essentially two stacks of EIGRP for IPv4 and IPv6, but the configuration is just much cleaner, and it's a much more of a hierarchical configuration. All of the configurations for EIGRP are done under the global routing process, as opposed to when you have some configurations that are done on the interface, some configurations that are done in the routing process, and so on. In traditional EIGRP, what we call classic EIGRP, a lot of the configuration is going to be fragmented throughout the entire configuration of the device. So you might have stuff running under an interface, you might have stuff running under a global process, and oftentimes the syntax isn't even very intuitive. I think in our last lesson I was trying to set up some hello and dead timers on the interface, which I've done hundreds of times before, and I had to use my question mark to figure out the syntax, because it just doesn't really make a whole lot of logical sense. There's really no kind of tie-in specifically to EIGRP in the beginning of the syntax for those particular commands. So if we're doing things like authentication, that's going to be done under the interface. If we're doing route summarization, that's going to be done under the interface, and so on. So here's an example. Let's say that I go into my topology here. This is the topology that we're going to be using for this class here. It's just a basic kind of branch, and headquarters topology. We already have EIGRP configured in IPv4 between these different platforms, but we are going to be adding IPv6 as well. So we'll go ahead and add IPv6 to this topology so you can see how that we can get this combined configuration. As far as the functionality goes, everything that we learned about EIGRP in our last lesson with regard to the algorithm, successors, feasible distances, and so on, all of that is going to be the same. The ability to control things like passive interface and distance values and being able to apply route maps and redistribution, all that stuff is going to be the same as well. But again, it's just going to be all consolidated under our address family configuration. So if I was to go into the HQ router, for example, and I do a quick show run pipe section EIGRP, this looks like a nice clean configuration because I'm just doing basic EIGRP in my global mode. And if I go into router EIGRP1, I can see that, let me try that again, router EIGRP1, I can see that I do have quite a few configurations that are available under the router configuration mode. But if I was to go into, say, Ethernet 1.0, I also have IP summary address EIGRP commands, IP authentication EIGRP, let me do IP authentication mode MD5. So that would be a mode EIGRP 1 MD5. So you can see how it's kind of annoying. You've got really not, you don't really have a predictable way of configuring all of these individual elements of EIGRP. So maybe some commands start with IP EIGRP, or actually in this particular case, none of the commands start with EIGRP. So you know, if you want to do a hello, let me see, IP hello interval EIGRP. So it just doesn't really make a lot of sense with the way they had this configured in the past. Now, it means that the configuration overall in EIGRP is going to be rather fragmented, and it's going to be difficult to kind of identify where the configuration elements are of EIGRP and how those configuration elements are configured. So like a summary address or EIGRP authentication, it's just not really intuitive. And I've been doing this for 20, 25, 30 years. And when I'm configuring some of these secondary functions of EIGRP, it's still difficult for me to kind of walk through and get those configurations down correctly. All right. So the main change that we see with named configuration is the format of the syntax itself. There is a much better parity between IPv4 and IPv6. The syntax is basically unified for both stacks, and it's unified under one process, okay? We use these things called address families to distinguish between the IPv4 and the IPv6 configurations. Now, there are some enhancements to using named mode as well. For example, the metrics that we use, and we'll talk about this, we'll actually have a separate lesson about this concept later on. We use wide metrics instead of the narrow metrics that classic EIGRP uses. Wide metrics allow me the ability to have larger bandwidth on my interfaces and my links. There was a limitation effectively with classic EIGRP based on the actual bandwidth field in the updates and the router updates that were sent back and forth. We can support things like IPv6 VRF Lite, which is virtual route forwarding without MPLS, and so on. So there's lots of kind of unique things that we can do with our named mode configuration that we didn't see in classic mode configuration. So one thing that I want to do real quick, because one of the things that's missing from this configuration, if I do a show IPv6 protocols, is we don't have IPv6 EIGRP configured here. So let's go ahead and put that in so that I can show you guys, at least on a couple of routers, so I can show you how some of these configurations might look. So let's do IPv6 unicast routing on this router to enable that. IPv6 router EIGRP1, no shutdown. And let me do a show IP route pipe connected real quick. So I'm going to go into interface Ethernet 1.1. We'll give this guy an IPv6 address 2001 DB8 ACAD :1:1/64. Oops, there we go. And we're going to enable OSPF or EIGRP on this interface, IPv6 EIGRP1. And let's do, I'll leave the loopbacks for now. We don't really need to enable IPv6 for EIGRP on these loopbacks right now, but let's go ahead and do it on BR1 as well. So config T, IPv6 unicast routing, and let's do a show IP route connected, and let's go into interface. Oh, let's do IPv6 router EIGRP1 no shutdown. And let's go into interface Ethernet 10, IPv6 address 2001 DB8 ACAD:1:2/64, and we'll do an IPv6 EIGRP 1. So we should get an adjacency there. I want to go ahead and configure some v6 addresses on the loopback interfaces as well. So let's go to loopback 0, IPv6 address 2001 DB8 ACAD:10:1/64, and we're going to enable IPv6 or EIGRP on that interface. And then interface loopback 1, we'll make this guy 11 and enable EIGRP on that interface. Interface loopback 2, this one will be 12, and we'll enable an interface loopback 3, this one will be 13. Oops. So this is all classic configuration. So if I do a show run pipe include or section EIGRP, you can see that we do have lots of different EIGRP configurations, but it's really kind of difficult to kind of identify where these EIGRP configurations are applied. We've got some global processes that are running. We've got some interface configurations that are done as well. And it's just really just kind of a fractured or fragmented configuration. Let me make sure I'm getting those routes. All right, and do show IPv6 route. Now, so I'm getting all the loopbacks, the 10, the 11, the 12, the 13. So we're going to leave that as it is right now. All right, and what I'm going to do is on BR2, we're going to go ahead and configure BR2 for with a named configuration. All right, now BR2 actually already has an IPv4 classic configuration. If I do show run section router, we can see that it already has kind of the classic configuration. Let me do a quick show IPv6 interface brief. I don't believe I have show IPv6 interface brief. All right, so let's add our IPv6 to this router first. Not the EIGRP routing, but let's add IPv6. So do show run pipe or show IP route. Pipe include connected and interface loopback 0 IPv6 address 2001 DB8 ACAD. And all I'm doing is kind of simulating these loopbacks. So this is subnetwork 64 for this one. The next one is subnetwork 65 and so on. Now I'm not going to enable EIGRP in this case because we're going to use the named mode configuration for this router. All right, now we'll go in to convert the other routers to our named configuration as we go through the process here. All right, and interface Ethernet 1.2, IPv6 address 2001 DB8 ACAD:2:2/64. All right, now I do believe on HQ show IP route I missed one. I got to do Ethernet 1/1/2. So config T interface Ethernet 1/2. IPv6 address 2001 DB8 :2:1/64. All right. And what the heck, we'll go ahead and enable EIGRP on this one as well, EIGRP 1. So we have EIGRP running on that interface. So if I do a show IPv6 EIGRP interface, we can see that EIGRP is running on Ethernet 1.1 and Ethernet 1.2. But again, we have that fractured configuration in this particular case. Now, if I do a show IPv6 EIGRP neighbors, I can see that I only have the one neighbor, which is on Ethernet 1.1, but that's because router 2 isn't running IPv6 for EIGRP just yet, because we're going to go ahead and configure router 2 in a named mode configuration. All right, that's what we're going to start with, and then we'll convert the rest of the routers. So to configure EIGRP named mode, of course, you still have to have iOS 15.x. So the first thing I'll do is a show version. And I'm running 15.2.4.S7 in this case, but you can always identify whether or not you can run EIGRP named mode by just doing simply a router EIGRP question mark, and you'll see that we've got this opportunity to create a virtual instance name for the EIGRP process. Now, this name is locally significant to the router. It is not something that has to match on all the routers, because we're not identifying in this particular case the autonomous system number. We do that under the address family configuration. Although I do like to kind of make the names match, they don't really have to match on all the routers. So we're going to go ahead and create our named EIGRP configuration by typing router EIGRP CCIE. Now, if I do a show IP protocols, you can see that I'm running EIGRP1, but I don't see any reference to the named configuration. And that's because the name itself does not actually start the EIGRP routing process. We actually have to go in and configure what we call address families. And you can see under with the question mark here, I have the option to create a service family. I can shut down or do a no shutdown on the named instance of EIGRP, and I have the ability to do my address family configuration. You can see I have two choices. I have IPv4 and I have IPv6. So these are what we call sub-address family identifiers within EIGRP that allow us to configure the different address families. You're going to see something like this also in BGP. If we're doing MPLS routing with BGP, where we're creating VRFs, and we have different address families for our multi-protocol BGP implementation, we'll see that a little bit later on. All right. We are advertising, in this particular case, attributes, but the underlying control plane is what allows us to actually establish the adjacency. That's going to be completely unrelated to the actual advertisements that we're going to be sending out. I'll show you a little bit more about what I mean by that as we start to get into the configuration. So if we want to, we can actually create address families for specific VRFs, which would end up being essentially another instance of EIGRP, or we can actually use the global routing table and include our EIGRP configurations in the global routing table. So if I say address family IPv4 autonomous system, this is where I would actually be creating the AS that would have to match on all of the routers for my v4 process for EIGRP. So the name itself is locally significant, but the address family autonomous system number is still has to match on all the routers in order for us to be able to form our adjacencies. Now I could come in here and I could say address family, this particular router, let's see if it supports it. Yep, so I could create a VRF for a specific routing instance, and then I can give that VRF a name, which would then allow me to essentially create another instance of EIGRP. In this case, we're going to basically create an address family autonomous system number for EIGRP. And so let's go ahead and do that. So we're going to say autonomous system number 1. All right. So, oops, I forgot we've got ASN number 1 already configured. So let's do no router EIGRP1. That takes out the old configuration. Now we can go and create our autonomous system number. Okay. Again, this autonomous system number needs to match on all of the routers. All right, we should see our adjacencies go down as well. We might see the adjacency go down for v4. All right. So this is the global routing table. What we're going to be doing is we're going to be incorporating the configuration of EIGRP with these address families directly related to our global routing table as opposed to a specific VRF. So we've enabled the routing process globally using autonomous system number 1. Our next step would be then to go ahead and enable EIGRP on the specific interfaces. This is going to be very similar to what we saw with classic EIGRP. So if I do a show IP route pipe include connected, I can see that I have 3 loopbacks and 1 physical interface that I would want to include as part of my EIGRP process. We simply use the network statement to do that as always. So I might do a network 10.64.0.0, 0.3.255.255. So that should include each of those loopbacks. Just make sure that 64 is actually divisible by 4. All right, which it is. So we can do a block of 4 starting at 64. That's essentially what this wildcard states. And then I can do my network statement for 172.16.0.0. I can put that in as a classful network statement because it is already a class B, okay? Now, granted, it is a /30, so any interface that starts with 172.16 would be included as part of EIGRP, but my point is that the network statements are entered the same way that they would be if you were running classic configuration. And you can actually see that we did form an adjacency because we're just enabling the EIGRP process, but all the packet types, all the frame types are going to be about the same. They're not exactly the same because we do have the ability to support wide metrics. And you'll notice in when we do the captures, we'll have another lesson, like I said, talking about that. You'll see that there is a slight difference between named mode and classic mode, but they are compatible with each other, okay? This is not the same as an OSPF. In OSPF, if you're running OSPF v3, it will not work with, you will not be able to form adjacencies with a classic OSPF configured router. All right, so we are, if I do a show run, pipe section EIGRP, we can now see that we have our topology-based configuration. We have our network statements that are entered in the address family itself. So this is the name of the EIGRP process. This is the autonomous system number, and this is these are the network statements that allow us to actually enable the protocol on the particular interface. All right. Now, if I went to the routing table, do show IP route, EIGRP, you would see that essentially it looks exactly the same. But what if I wanted to look at an individual route in that routing table? So do show IP route 10.10.0.0. You will notice here, and we'll see this will change later on, but you'll notice here that, that we're getting this routing information just like we normally would. We've got a delay in microseconds. We've got a minimum bandwidth in kilobits per second. So these look like normal metrics to the routing process. Once we convert the other routers to the named mode configuration, you'll see that that will actually change. Now, with regard to the topology, the base topology, if we do a show run section EIGRP, you will see that there is a reference to something called the base topology or the topology base. It's actually technically referred to as the base topology, but this means that all the links would fall under this particular category. I'm going to show you guys that a little bit more and talk about what we can configure under the topology base. But there are several things that we would actually configure under the topology base that would apply to the links like a default. All right. Now we do have network statements. The named process and the classic process are, like we've already demonstrated, are completely compatible with each other. And we can customize this configuration as well. So let's say I wanted to set up authentication between the HQ router and the branch router. All right. So I want to ensure that we have some sort of authentication. Now, if I was using the classic mode configuration, I would have to actually go into the interface and I would have to specify my authentication mode as MD5. I'd have to set up my keychain, create my keychain globally, and apply my key string to the key, or create my keys with my key ID and my key strings, and then I would apply that authentication to those two routers. Actually, let's go ahead and do it. So let me do a show IP EIGRP neighbor. We're going to apply this to the top neighbor because it's still running classic mode, which is going to be on interface Ethernet 1.1. So config T, interface Ethernet 1.1, IP authentication, and we're going to go ahead and say mode, EIGRP. We're running autonomous system number 1, and we're going to set the mode to MD5. We're also going to set up our authentication keys, IP authentication. All right, and let's see, our keychain is going to be for EIGRP1, and we'll just call that keys. And then we have to go to global configuration mode and actually create the keys. So keychain keys and key 1, and let's go ahead and give that a key string of CCIE. All right, so now I would lose my adjacency, show IP EIGRP neighbor, because I've configured authentication on one side of the link, but I haven't configured authentication on the other side of the link. So if I do a show run interface Ethernet 1.1, I should be able to just copy this, of course, and paste this into my branch router. Enable config T, interface Ethernet 1.0. All right, and let me do a show run section keys real quick. Show run pipe section keys. And I should be able to copy my keychain as well. There we go. And once I paste this in, then my adjacency should come back. All right, there we go. I've got my adjacency. But again, if I do pipe section authentication, pipe router, you can see, oh dang it, you can see that again our configuration is fragmented throughout the configuration. In fact, I can even come in here and throw in keys as well. So I've got the authentication commands that go under the interface. I've got a keychain that I have to create globally. And then I have the network statements and the global configuration commands under the EIGRP process. All right. So it's kind of difficult to parse the configuration and identify where the configurations exist. And this gets exacerbated when we're doing things like route summarization and so on. In fact, let me show you that part of the process. Based on our topology diagram here, we've got, oh, we got a chat message here. Hold on. What's the difference between the section and include? Oh, so the section pulls out an entire section of a configuration, where include only pulls out an individual line, right? With grep commands, you can do a begin, you can do a section, you can do an include, you can do an exclude. I love the section one because it will pull out anything related to that particular section. So, you know, when I go into my router here and I do section keys, because that line starts with keys, and because these are sub-configurations within that group, it pulls out that entire section for me. Same thing here, when I do a section router, because these are sub-configurations of router, it pulls out that in section. If I did a show run pipe include keys, it would only pull out that individual line that has the word keys in it. And it is case sensitive, by the way. So I like to use the section one instead of the include because you get to see the whole configuration section. Yep. Actually, and that's actually a good thing, Mike, because when you're doing your troubleshooting on the CCIE, you need to save time. So you need to be able to do these grep commands quickly. The grep commands work for all kinds of show outputs, not just the running config. So it really, if you get really good with these grep commands, you can find things pretty quickly. Yep, there you go. All right, so where was I? Oh, going back to my topology here, I want to summarize these subnets here, 10, 11, 12, and 13. And we're going to create a summary for branch. So let's do that on our branch router. Now, this is, again, another example of where we have a fragmented configuration. Because when we do summaries in OSPF, the summaries fall under the OSPF global process. But when we do summaries in EIGRP, we do the summaries on the interface. So we're going to do 10.10. Actually, we have to do 10.8 in this case. 0.0, 255, 252.0.0. Okay, so I'm summarizing networks 8, 9, 10, 11. That should do it, right? 8, 9, 10, and 11. Nope, I got to do, actually you have to do a block of 8. It's not a great summary, but it should work. I don't think it's going to conflict with anything else that we have here. So I've got to do a block of 8 here instead of a block of 4. So I'm summarizing from 8 all the way up to 15. So again, it's just a basic summary configuration. Now if I go to my HQ router and I do a show IP route, we will see that we're seeing that summary. Let me just pull out pipe include 10.8. So this is the summary that we're getting. One of those will go away. We're in a hold down time. Remember, this is a distance vector protocol, so it's kind of holding down that first summary I did for a period of time, but eventually that will go away and we'll get our single summary, which is our /13 that we wanted to send in. All right, so I'm getting a summary, but again, that's not really the point of this conversation. The point is that we just, again, have another fragmented configuration. Authentication is done on the interface, summaries are done on the interface, and the rest of the stuff is done in or not all the rest, but a lot of the stuff is done in the global routing configuration mode. All right. Now, there are some things that we can do within address families. For example, let me go ahead and set up the authentication and this is kind of nice. So let's say on branch 2, I've decided that I'm going to go ahead and run authentication for all of the routers that I'm connecting to. Now, in the classic config, I would actually have to apply this configuration to every single interface that I want to run the authentication on. In the case of this configuration, let me start from the beginning, okay? And I'm going to do config T, router EIGRP CCIE, and I'm going to do the address family IPv4 and unicast autonomous. You actually don't need to put in the unicast. It will actually accept it without the unicast command. I actually did that the last time. Autonomous system number 1. And there is a thing under here called AF interface. So if I go into AF interface and I hit a question mark, you'll notice that I have all the interfaces that could exist on this platform, but I also have one called default. Okay, so if I did AF interface Ethernet 1.0, for example, this is where I could apply all of those specific interface types of commands that normally would be done under the interface. Authentication, bandwidth %, if I want to specify how much bandwidth the EIGRP is going to use on the interface, bidirectional forwarding detection. We'll talk about dampening a little bit later on when we get into DMVPN. Hello intervals, hold times, next hop self, again DMVPN, passive interface, split horizon configurations, summaries. So these would normally be all the configurations that I would be applying in the scope of classic configuration. These would be all the configurations that I would apply under the interface. Now I do have an AF interface default that I could do as well. Now what AF interface default is, that means that we're going to be applying this will be the default configs that are applied to any interface that's running EIGRP. So if I did passive interface, for example, I will see my adjacency go down because I've made all of my EIGRP interfaces passive by default. And then I can go specifically into, say, for example, AF interface Ethernet 1, 2, and do no passive interface. So I can make that interface not passive. So again, by applying these configurations under the address family, we're not having to go into the specific interfaces and apply these configurations. So let's say, for example, let's go back to AF interface default, and I want to apply the authentication. Okay, so now I'm back in the default interface. I can now say authentication, keychain, keys, apply the keychain to the interface, authentication mode, EIGRP, well, it's actually already applied under the address family because I'm already in the address family, so I don't even have to specify the autonomous system number. So now I've applied authentication to that neighbor. Now, granted, I broke the configuration because I hadn't configured authentication on this interface, but let's do a show run interface Ethernet 1.1, show run interface Ethernet 1.1, and let's go into config T, interface Ethernet 1.2, and I'm just going to copy these. I've got to set the keys up on the other router as well. That is one thing that will not work. Let me do a show run pipe section keys. That's one thing that will not work in address family mode, is because the keychains can be used for lots of different authentication processes. So I still have to configure the keychain in global configuration mode. All right. So now I've got my adjacency back. But again, if I do a show run pipe section EIGRP, I have everything configured in this address family configuration. So I've got my authentication on my default interface, which means any interface that, continuing on. So, you know, because if I wanted to run authentication with 20 different peers, because I've applied this to the AF interface default, I don't have to worry about doing this on every single interface, right? I've also made all my interfaces passive by default. And then I have specific configurations that go under AF interface Ethernet 1.2. But this is my entire EIGRP configuration all in one grouping. All right, so now let's complete the configuration. Let's go ahead and add our IPv6 config T, router EIGRP, CCIE, and let's do address family, in this case, IPv6, unicast, and autonomous system. We'll use the same autonomous system number. All right. Now, you'll notice here in this case, we don't really have the ability to do network statements, but you also notice that it automatically enabled EIGRP on all of my interfaces by default. That's something to keep in mind when you're dealing with EIGRP for IPv6, because we don't use network statements. By simply enabling the address family subconfiguration, it automatically enabled EIGRP for IPv6 on my interfaces. So I've already established an adjacency between those neighbors. Okay, and we could do all kinds of things. We could add authentication here. Now, authentication with IPv6 is a little bit different. We actually do have a lesson where we'll talk about authentication for EIGRP. So I haven't really been going slow on that part of the process yet, because we're going to have a whole lesson about IPv6 authentication and IPv4 authentication with these routing protocols later on. All right, but again, if I do a show run pipe section EIGRP, I can see a nice clean configuration for EIGRP. I see everything here. All right, it does get a little bit longer, of course, because we're applying all of these individual concepts. So let's go ahead and continue on. let's do our summarization for our topology here. We already did our v4 summarization here. Let's do our v4 summarization here, which we're going to do on Ethernet 1.2. I'm also going to make BR2 a stub router. That's another concept that we're going to talk about in a different lesson. But I just want to show you how kind of all of these features would be configured under the specific process that we're trying to configure. So let's create, or the address family configuration. So let's create, we got 64, 65, and 66. So that'll be 64 with a block of 4. Let's do that on BR2. All right. But because we're running named configuration, we're going to need to go into address family IPv4, unicast, and autonomous system number 1, and AF interface, because this is going to be, now we could do this as a default, by the way. So if I wanted to advertise the summary out of all of my interfaces, it's smart enough to figure out not to do it out certain interfaces, but if I wanted to do this out of all my interfaces, I would just do a summary address, IP summary address. Why is it not taking it? Maybe it won't let me do a summary under the default. Let me try it under AF interface Ethernet 1.0. Summary address. Yeah, so apparently it doesn't allow me to do the summary under the default. I thought it would, but it doesn't. So in this case, 10.64.0.0, 255.254. Actually, we need a 252 in this case, 00. All right. And if, sure enough, if we go over here and we do a show IP route, pipe include 10.64, we'll see that summary coming across as a /16. That makes sense. That does not make sense. Why is it coming across as a /16? It should be coming across as a /14. 64. Yeah, that's perfectly legal. That's interesting. Why is it coming across as a /16? It's definitely coming from router 2, but it definitely should not be coming across as a 16. Let me do a show IP EIGRP topology here. And it is, oh, I see. Well, that's interesting. The summary's not coming in. Do show run pipe section EIGRP. You know what? That should work. Let me try and change this real quick. Let's do a no network. And let's just do a network 10.0.0.0 and see if all those other loopbacks come across here. Show IP route. So the loopbacks are coming in, but I'm not getting the summary. Let me check one more thing. Config T, do show run pipe section EIGRP. I may still have to put in the autonomous system number as part of the summary, which I didn't do here. It's probably not injecting the summary because I didn't put in the AS. Let's see if that will fix the problem. Oops. And let's go into address family. And let's go into the interface. Let's do a no. And let's do a summary address. Yes, it didn't let me. Interesting. 10.64.0.0.255.252.0.0. Show IP EIGRP topology. there's the 16, there's the 8, the 16, the 16. All right, well, it helps if you have the right interface. So let me fix that. I did it under Ethernet 1.0, and obviously it's supposed to be Ethernet 1.2. So let's do show run pipe section EIGRP and fix that problem. All right. And address family. And let's take out AF interface Ethernet 1.0 and do AF interface Ethernet 1.2. That's why. I was thinking I did the authentication under the interface, but I did the authentication under the default interface. And then I did no passive interface under Ethernet 1.2, but I didn't do the summary correctly under the right interface. So now we should see that null zero route, show IP route in our routing table. So there's the null zero route, which means that the summary is being created. And it is coming in as a /14. Show IP EIGRP topology shows us that the summary should be in here as well. 6400 via summary, also tied to the null zero interface. In our HQ router, we should no longer see the individual routes. We should see the summary route. Yep, there we go. Well, you know, that's the kind of stuff on the lab that will just kill you. So pay close attention to what you're configuring. Otherwise, you're going to get a lot of time wasted on all right, a lot of time wasted on that. All right, let's see here. So we've created the address family. I think you guys have a pretty good idea about how we can take a lot of these configurations. Let's say now I wanted to configure BR2 as a stub router. All right, show run pipe section EIGRP. All right. Let's say I want to go ahead and configure this stub configuration. Again, we'll talk about what an EIGRP stub is a little bit later on. That's another topic. But let's go into our CCIE EIGRP configuration. And we're going to go into our address family. And now this is stub configuration is something that applies to the router as a whole or the routing process as a whole. It doesn't apply specifically to an interface. So almost all of the stuff that we're going to do that applies to the routing process as a whole is going to be done under topology base. So we've got auto summary. We can change default metrics for redistribution. We can modify administrative distance. We can do a maximum paths for load balancing. We can apply offset lists. We can redistribute. So again, these are all variants. These are all the things that would apply to the overall EIGRP routing process as opposed to a specific interface configuration. So for example, EIGRP, that's where we're going to get our stub configuration. Let me see here. So actually I thought that EIGRP stub configuration was going to be in the topology. It's actually under the global address family configuration. So I'm in AF autonomous system number 1 for IPv4. And I have the ability to configure my stub configuration here. So if I do stub, I can do, well, I just saw it. Oh, EIGRP stub, sorry. So I can do my stub connected and summary here. So I'm advertising my connected routes and my summary routes. Stub configuration, like I said, we'll talk about a little bit later on. In a different lesson. It has to do with how we handle the query process and what we advertise to our upstream neighbors. But again, show run, section EIGRP, everything is done under the configuration for our named configuration. So you can see how this could be really useful because you have one section that you need to look at for the configuration. So this applies to the global routing process for IPv4. Much like the network statements do. We could certainly do this in IPv6 as well. So if I went into the address family for IPv6, I could basically run the same command, and create myself as a stub in IPv6 as well. So a lot of the things that we can do in IPv4, we can do in IPv6. Let's say, for example, let's continue on and apply this configuration. I want to summarize 64, 65, and 66, the 64, 65, and 66 subnets here with an IPv6 summary address. So I'm going to go back to BR2, and in our summary configuration, we do the summary under the interface. So I'm going to go to interface, AF interface, excuse me, Ethernet 1.2, and I can do like no passive interface, just like IPv4, and I can do my summary address, 2001 DB8 ACAD colon 006, and we're doing 4, 5, and 6, which would be it would be 4. And we would be doing 4 bits or 4 addresses. So we'd be doing 4, 5, 6, and 7, which would be a double colon slash 4, 5, 6, and 7. So that'd be a 62. All right. So again, show IP route, IPv6 route. We've got our null 0 route here. One of these interfaces here. Null 0 right here. So there's the null 0 for our summary route. And if I do a show IPv6 route, I'll see that summary here as well, the /62, which is right there. Okay, it's kind of cool actually when you get into the configuration and you kind of apply all of the settings that we've already learned about, right? How do we summarize an EIGRP? What is a stub routing configuration? What is authentication? The only challenge is maybe perhaps finding where it specifically goes within the address family configuration. Does it go under the topology base? Does it go under the AF interface, and so on? All right. You could do this with timers. You could set timers, hello and dead timers. I mean, I could keep changing a bunch of different configurations here, but I think you guys get the general idea of how this configuration works. All right. If I was to do all of these things that I just did in a classic configuration, you would see, for example, that configuration is really, really fragmented. You'd have stuff on the interfaces, you'd have stuff in the global routing process, and so on. All right. So we've done passive interface, we've done no passive interface, we've done an AF interface default configuration, all kinds of things. All right. Now, if I want to run IPv6, all I have to do is just change from address family v4 and v6, and the syntax that we use on one is essentially the exact same syntax that we might use on another. All right. Now, it is slightly different for v6 authentication. We don't use authentication mode and authentication keychain. We use the built-in IPv6 authentication extension headers and ESP extension headers that are built into IPv6 to establish the process. But let's say I did want to run authentication for IPv6 between the two routers. I'm not going to configure the whole thing because I've got to generate keys and whatnot, but I go into the address family, I go into the interface, and I just simply say IPv6 authentication, or authentication probably. There we go. And then I can say mode, and I can specify SHA-256, or I can do encryption. I should be able to do encryption. Let me see. This one, I'm wondering if I may have to do that under the default interface. I'm in the v6 address family. So normally if I'm configuring authentication and encryption for IPv6, I would simply use the authentication and encryption commands. It might be slightly different though with OSPF and EIGRP. Typically I'd be able to specify the actual key string that I'm going to use. So the encryption type 0 and yeah, the password here. So I would set the key string for authentication here, but there should be an option. Let me do AF interface default real quick. If there's an option for encryption there. No. We'll take a look at that later on. I may have to switch to a different version of code to support that function. But again, you would configure it under the address family and set up that configuration under the address family, which we're gonna have a whole lesson on authentication a little bit later on. Okay. When we deal with topology base, we're actually dealing with something called multi-topology routing. You might see something like this, for example, if, let me see, where's my paint right here. So you might see something that looks like this. This is pretty typical when we're talking about BGP. You've got what we call a base topology. And then within that base topology, you might have other topologies that you're running, like a red topology and a green topology and a blue topology. These would end up being different MTR topologies, meaning that we have multi-topology routing. And what would happen in this case is that we could actually apply different routing principles and policies in our enterprise based on what we're putting over these different base topologies. So for example, if I had several routers in my infrastructure. Hold on one second. So let's say, for example, I had some sort of routing topology, and in that routing topology, I had, a few different routers. So there might be a router there, there might be a router there, router there, router there, and I have all these links between these routers and different connections or whatever. Well, I might decide that the red topology is going to route this way, the blue topology is going to route this way, the green topology is going to route maybe this way, green, this way, and so on. But by splitting up the routing information into different topologies, that would give me the ability to route over these different links. That's not really what we're talking about here. We're using that same technology to create the address family. But something like this we'd be doing in like MPLS traffic engineering, or if we're doing maybe class-based tunnel selection based on QoS marking, sending different traffic like QoS A, any traffic marked with a QoS tag of A is going to get sent over tunnel A, and QoS B is going to be sent over tunnel B, and so on. But the idea is that we're making different routing decisions based on different routing policies. So that's kind of what we see with the topology base in EIGRP. Now, if I look at the topology base in our EIGRP named configuration, you can see some of the familiar things that you guys are used to seeing with EIGRP. All right, actually, let me do one thing. Let me do a topology question mark. Yep, so in this case, we can only deal with the topology base, but we looked at some of these already. Distribute lists, that would be applying inbound and outbound filters to relationships or partnerships or peering relationships that I have. Setting administrative distance, redistributing, say, EIGRP or OSPF or ISIS, specifying the summary metric when we're applying metrics to our summaries, specifying the timers. All right, so for example, timers, I can specify the active time for active state and so on. That would be for like if I lose my successor and I don't have a feasible successor and I go into an active state during the query process. Usually the timer is going to be 3 minutes. I can specify variance for unequal cost load balancing if I want to do unequal cost load balancing. And the concepts are still the same. The principles of these elements are these configuration components that we talked about in our classic configuration are the same. All right. So that's what we'd be doing under the topology configuration. All right. So we could go ahead and rebuild our configuration. On some of the other routers if you want to. I'm hoping this is going to work in this case. but let's take a look and see if this will work. Let's say that I wanted to convert HQ to our named configuration. This does depend on the iOS. I think you have to be running at least 15.4S, and I don't think we're quite there. We're at 15.2, but let's see if it'll work. There's a command that you can run under the EIGRP Classic configuration where you can say the upgrade. Yeah, it's not here. Shoot. All right, upgrade. I'll type the command so you can at least see it. CLI CCIE. And what it would do is it would take, you need 15.4 to run this, but it would take your classic configuration and it would convert the entire classic configuration to a named configuration. All right. Obviously, it doesn't work in this case because we have to be running 15.4S. And it actually doesn't kill the EIGRP process. The conversion is hitless. That means we do a graceful restart. The neighbors are going to flap, but the data plane is still going to function in this case. It's kind of like stateful switchover, where the data plane is just fine, but we reconverge based on the control plane configurations, and then we keep forwarding the information. So let's go ahead and switch HQ to the named configuration. Because I'm not doing any of the special features, well, I am doing authentication, so I'm going to have to apply that. Actually, what I could probably do is just grab the configuration from BR2 and kind of parse through that config, and then I can just paste it in. Show run pipe section EIGRP. So I can grab this named config from here. Let's see. Let me get the whole thing. I'll drop that into Notepad here. I haven't done any notes here, but I don't really think we need notes here, honestly. So we're not going to do a summary there. We can take that out. We're doing network 10. Let me do go back to HQ here. Show IP route pipe connected. 172.16 is the only one we're doing on HQ. All right. And I'm not going to configure this router as a stub router. And I don't need to do passive interface. I'm not doing a summary on this interface either. I actually can take that out too. I am going to be doing authentication. Yep, that should just about do it. So I can take this configuration here, which is nice because I was able to essentially copy the entire configuration and modify it slightly. And now I can put this configuration into my HQ router. So let's get rid of our classic config, no router EIGRP1. Do show run pipe include EIGRP because I think we still have some authentication stuff configured. Actually, I have to leave, yeah, I can take that out as well. No IPv6 router EIGRP1. And that should just about do it. So now I'm going to take my config here and I'll paste that config in. We got one error there, but that's okay. We didn't have to do an exit AF interface because we weren't in an interface. So you can see that I've got my adjacencies back up. I've got the adjacency with Ethernet 1.1, Ethernet 1.2. Now, there is something kind of interesting about this. If I do a show IP EIGRP neighbor, I don't see neighbors there. Let me do a v6 neighbor. So I do see neighbors here. I'm missing my v4 adjacency though. Let me do a show run pipe section EIGRP. Could be an authentication problem, although the keys should be okay. Oh, I've got passive interface default. Yeah, that's gonna break my. I've got to do a no passive interface on on both my interfaces actually. Do show IP route pipe include connected, and let's go into EIGRP configuration mode. I could just simply take it off, but let's go ahead and do AF interface Ethernet 1, no passive interface. Obviously, it would be probably better for me AF interface to take off the passive interface since all my interfaces are not passive. But that's okay. It gives us a chance to kind of see the rest of the config. All right, no passive interface. Okay. So I've got my adjacencies now. Show IP, EIGRP neighbor. Got my adjacencies. Now you'll notice here that we see the virtual routing instance for EIGRP, and these are the neighbors under address family IPv4 for AS1. So a lot of the show commands that we're going to run, they're going to be the same as they were before. The only difference in this case is that we're running address families instead. All right. As I said, we were running classic mode on this router before, but because classic mode and named mode is compatible, we don't have a problem with that. All right. EIGRP, as you guys have probably already seen from a lot of the configurations that we've been doing, is a really, really simple protocol to run. You basically just turn it on the interface and it's going to work. We don't have to deal with different properties of the neighbor relationships like we have with OSPF. Certainly authentication is going to have to match, and there's some other values that have to match, but it's there's no down state, init state, two-way XStart exchange, loading in full. It's just you're either a neighbor or you're not a neighbor. Okay. Now it is a distance vector protocol, like we learned in the last lesson. So we're only going to be advertising what we're using in the actual routing table. So nothing else we're going to need there's nothing that we'll actually need to form an interoperability process between the two neighbors other than the neighborship that we've created. All right. So if we look at the attributes or the EIGRP topology table, let's do a show IP, show IP EIGRP topology. We can see that the topology table looks essentially the same. But you will notice here that something has changed quite significantly. These values here are much larger than they normally would be. And this is where the concept of wide metrics comes into play. So let's say I want to look at the 10.8.0.0/13 route, show IP route 10.8.0.0. You will notice /13. I should be seeing this in picoseconds. Let's do it this way. Show IP EIGRP topology 10.8.0.0/13. So we're seeing, there we go. There's my delay in picoseconds. That's what I was looking for. So we're seeing that we're dealing with what we call wide metrics in this particular case because both routers are running named mode configuration. So we see our standard feasible distance here, which is kind of what we would typically see. But the number next to it is actually not, this number doesn't actually get installed in the routing table. If I look at the routing table here, the metric is 358/4000, so it's the actual RIB information that goes into the routing table. We'll talk more about this when we get into the wide metric options and configuration for EIGRP. That'll be one of our next lessons that we're going to cover. But you can see here that the total delay now is listed in picoseconds instead of microseconds. Let's see if we can see anything different with the actual updates as well when we send out our routing updates. So I'm going to kill one of the loopbacks once we get our capture started. And I'll restart one of the loopbacks and see what we see in as far as the metrics in the routing table, or in the updates that we're sending back and forth. All right. This concept of wide metrics is actually built directly into the named mode configuration, so we didn't have to turn it on. It was something that was supported, but it is backwards compatible with, the process is backwards compatible with, let's filter out the hellos here. Oops, I meant to do and not selected. Let's get rid of the V4 and the V6. And not selected. And let's get rid of the hellos here. And not selected. All right. So let me go to my BR2, and I'm going to shut down one of those loopbacks so we can get an update here. Config T, interface loopback 0, we'll shut that down and do a no shut. And I should see in my Wireshark capture an update for that particular route. Got the hello. Where is the update? Let me do this. I want EIGRP. There we go. And I should be able to apply filter, selected, and update, I believe, is opcode 5. No, that's hello. What's 3? Query 4, reply 2. Should be an update. Now, why am I not seeing it? Let's try that again. Actually, let me do one other thing. Let me do it on the HQ router. Well, I don't have any interfaces. I've got this guy configured as a stub too. It shouldn't really affect the output there. Let's do this. Show run pipe section EIGRP. And let's go into there. And let's do no EIGRP stub connected in summary. Oh, we need to go into the address family and then no. All right. So now if I go into interface loopback 0, shut that down. There's an update. That's what I was looking for. All right. So this is a V4 update coming from 2.2, which is my router here. What I'm looking for here, actually 2.2 is the top link. Did I do a capture on the wrong interface? I'm going to kick myself in the butt if I did that. Yeah, I think I did actually do a capture on the wrong interface. It's the downside to teaching all day and then coming here and teaching again for 2 more hours. You get a little bit tired. Well, it says I am capturing on that interface. Let's try it again. All right. Show IP interface brief. Let's make sure I'm in the right router. I know it has the right name. And we are in the right router because there's 64, loopback 0, interface loopback 0. Let me wait till it gives me the response that the interface is shut down. Make sure that it's fully shut down. There we go. And do a no shut. Well, now my capture's not running. What the heck? Let's Start Wireshark. I might have to do that shutdown one more time. So what I'm trying to capture here, just to give you guys an idea, is I'm trying to capture an update so I can show you what the difference is between how the metrics look in this update using the wide metrics as opposed to what we see in the classic configuration with the standard metrics. If we don't get to see it this time, we'll certainly see it next time when we get into our wide metric discussion. But let's go see if we get it one more time. One more try here. All right. Shut that down. Okay. And do a no shut. And let's see if we actually capture an update. What should be happening is my router should be sending out an update indicating that that network changed. Let's see if this one is it here. So this is coming from 2.2. Looking at my topology here, that is the right IP address. But I'm not seeing information about the actual route in this case. I would expect to see information about the route. It would come after this authentication section here. This is actually the EIGRP header. So what you're seeing here is part of the EIGRP header, but I'm not seeing the update itself. Let me go back to Wireshark real quick and see if... All right, I'm going to do one more thing. And then if this doesn't work, we'll move on. So I'm doing my capture. Let me make sure it's still running here. So I should be getting hellos. Yeah, it doesn't look like my capture is running now. Kill it. One more thing. Bear with me, guys, here a second. So I'll go ahead and stop the capture on this interface and try it one more time. Hopefully it will launch Wireshark this time. There we go. All right, what I'm going to do in this case, rather than kind of going through the process of trying to get the shutdown and no shutdown to work, is I'll just add a route on this side. So if I do a show IP route, or show run, section EIGRP, because I do have the named configuration here, it should be generating wide metrics when it sends out an update. And it looks like I've got no passive interface, no passive interface. My network statement is 172.16. So I'm going to do a show IP route pipe include connected. And I'm just going to create a loopback interface. Interface loopback 0. Oops, let's do 100 in this case. And let's do an IP address of 172.16.10.10. 255.255.255.255. All right, so that interface should automatically be included in EIGRP. And if I go to my branch router, I do a show IP route EIGRP, I should now see that 10.10 route, which means I should have gotten an update in here to indicate that that route came up. And I don't see it. All right. I give up. We will take a look at this later on. Really all I'm trying to show you is how the update looks differently. Clearly it's going out, but I think there's something going on with Wireshark here. It's not capturing the information correctly. So we'll just leave it at that. But when we get into our next discussion about wide metrics, we will definitely take a look at how those updates look in Wireshark compared to what we see normally in a classic mode configuration. All right. But the wide metrics piece that I mentioned, definitely built into the process automatically. All right. Now, if I do grab another capture here, in this case, it doesn't really matter if it's a live capture or not. Oops. Because I just want to show you one other thing. Stop the capture. And let's go ahead and start the capture again. So what I want to show you here is the version that's indicated in EIGRP versus what we would typically see, right? We're used to seeing version 2. That may still be the case, but in our hello packets, we're also advertising the version of EIGRP that we're running. And I know that we definitely saw plenty of hello packets, so I'm going to show you guys that as well. In the case of classic EIGRP, we did talk about the feasible distance being used in the routing table. Now it is the RIB information, okay? That's what we're seeing in the routing table these days. All right, let's see. Am I actually capturing? It's okay if I'm not, because I really just want to go in here and show you under this configuration the software version. So we don't really see too much different here. We're running version 11 and TLV version 2.0. So this is why it is backwards compatible with the classic mode configuration. All right, is because we're actually advertising essentially the same version of EIGRP. Let me see. If we've got something else here. You know, I'm thinking that these might still be the old EIGRP updates. Definitely something strange going on with my Wireshark capture here. I think when I applied a filter, let me check one more thing. I may have a few different Wireshark instances running in the background. It might be causing havoc with my PCAP. It does say 3 in that task. See if it kills the other processes there. Okay, it killed the other processes. All right, no other Wireshark processes running. Because I should be seeing active captures, obviously, as part of the process here. Stop the capture. Try the capture one more time. All right, while that's loading, let's just kind of wrap up our discussion here. We have much more granular metrics, much more granular delay values. Like I said, I showed you guys that we're dealing with things in picoseconds as opposed to microseconds. So we get much more granular information in the metrics. So this is going to allow us to account for much higher interface speeds, like 100 gig, as opposed to like 10 gig or 1 gig. Yeah, see, that's really interesting, guys. You can see it here. It seems to be opening up the same capture every time. Like somehow it's frozen in time. So I'm guessing that what we were seeing in the captures that I created were, because see, we're not even seeing packet counts increase here or anything. So I think, let me see, apply, filter, selected. I think one of my filters is kind of stuck in there in the Wireshark, because that's when the problem started, when I stopped getting my captures. But anyway, we'll just leave that for now. We'll see that the next time. I'll make it a point to show you guys what I'm trying to show you the next time. All right, but the case of wide metrics, it's actually really important, because now we're starting to see more and more that companies are going to be implementing these high-speed interfaces, and they actually need to switch to named mode to be able to support the granular metrics that we need for those particular high-speed interfaces. All right, and I mentioned the whole classic routing process configuration command, the upgrade CLI CCIE command. Unfortunately, it doesn't run in this particular version, but it does convert the process very, very quickly. I was hoping to be able to show you guys through a ping process. I could run a persistent ping and do the conversion process, and we wouldn't lose a single packet. It's a completely hitless conversion process. All right, so that's about it, I guess, for our named configuration. We will see some more of this because we are going to be doing another exercise with wide metrics. So I'll use this same topology to discuss that aspect. But we'll be doing that in another lesson a little bit later on. All right? Are there any questions about this configuration, about setting up topology mode, EIGRP, as opposed to classic mode? Any questions at all? No? Okay. All right. Well, guys, it was a pleasure, as always, having you in class. I'm going to go ahead and stop the recording.